Download this code from codegive.com, link in the description below. Sure. The esp32 cam is a low-cost camera module that integrates the esp32 chip, allowing for various applications, including object detection. In this tutorial, we will use the esp32 cam with TensorFlow Lite to perform simple object detection. Requirements: 1. Hardware. esp32 cam module. ftdi programmer, USB to serial converter. Jumper wires. Breadboard, optional. 2. Software. Arduino IDE. esp32 board package installed. TensorFlow Lite, for microcontrollers, model for object detection. Libraries: esp32 camera, Wi-Fi, webserver, and httpclient. Setting up the esp32 cam. 1. Install the esp32 board in Arduino IDE. Open the Arduino IDE. Go to File Preferences. In the Additional Board Manager URLs field, add. Go to Tools Boards Manager, search for esp32, and install it. 2. Connect the esp32 cam to your computer. Connect the ftdi programmer to the esp32 cam. GND to GND. VCC to 5V. TX to RX. RX to TX. GPIO 0 to GND, to put the esp32 in programming mode. Connect the ftdi programmer to your computer. 3. Select board and port. Go to Tools Board and select AI Thinker esp32 cam. Select the appropriate COM port from Tools port. Code for object detection. Here's a simple example of how to set up an esp32 cam to capture images and perform object detection using a pre-trained TensorFlow Lite model. Explanation of the code. 1. Camera configuration. The camera_config_t structure initializes the camera settings. Adjust the pins if you are using a different esp32 cam module. 2. Wi-Fi connection. Replace your _SSID and your _password with your actual Wi-Fi credentials. 3. Web server. A basic web server is set up to serve an HTML page with a placeholder for a video stream. 4. Setup function, initializes the camera and connects to Wi-Fi. 5. Loop function, handles incoming client requests. Object detection. For actual object detection, you will need to integrate a TensorFlow Lite model, which is outside the scope of this basic tutorial. You can refer to the TensorFlow Lite documentation for converting a model to TF-Lite format and loading it onto the esp32. Uploading code. Make sure to select the correct board and port. Click on the Upload button in Arduino IDE. If the upload fails, press the Reset button on the esp32 cam module. Testing. 1. After the code uploads successfully, open the serial monitor in the Arduino IDE. 2. You should see the esp32 cam connecting to Wi-Fi. 3. Once connected, access the IP address shown in the serial monitor from your web browser. Conclusion. This tutorial sets you up with a basic esp32 cam project. For advanced object detection, you would need to integrate TensorFlow Lite model inference into the code. You can find numerous resources and examples online for specific models suited for microcontrollers. Feel free to ask if you need further assistance or more detailed explanations. Certainly. In this tutorial, we'll go through how to set up an esp32 cam module to perform simple object detection. We'll use the esp32 cam's onboard camera and the Arduino IDE to write the code. For object detection, we'll utilize a pre-trained TensorFlow Lite model. Prerequisites. 1. Hardware needed *. ESP32 CAM module. FTDI adapter or USB to TTL converter for programming. Jumper wires. Breadboard, optional. A computer for coding and uploading the sketch. 2 software needed asterisk. Arduino IDE, installed and set up for ESP32. TensorFlow Lite model for object detection, example MobileNet SSD. Step 1, setting up the Arduino IDE. 1. Install the ESP32 board asterisk. Open Arduino IDE. Go to File Preferences. In the Additional Board Manager URLs field, add the following URL. Go to Tools Boards Manager, search for ESP32, and install the package. 2. Install required libraries asterisk. Install the TensorFlow Lite library. You can find it in the Library Manager. Sketch include library manage libraries. Step 2, setting up the ESP32 CAM. 1. Wiring asterisk. Connect the FTDI adapter to the ESP32 CAM as follows. FTDI TX to ESP32 RX. FTDI RX to ESP32 TX. FTDI GND to ESP32 GND. FTDI VCC to ESP32 5V. Connect GPIO 0 to GND, to put the ESP32 in programming mode. 2. Upload a simple camera sketch asterisk. Load an example sketch to test the camera. Go to File Examples ESP32 Camera Web Server. Change the camera settings in the sketch as per your ESP32 CAM module. Upload the sketch. Once uploaded, disconnect GPIO 0 from GND and reset the ESP32 CAM. Step 3, Object Detection Code. Here is a simple example of using TensorFlow Lite with the ESP32 CAM for object detection. Step 4, Uploading and Testing. 1. Upload the code asterisk. Replace your _SSID and your _password with your Wi-Fi credentials. Upload the code to the ESP32 CAM. 2. Test object detection asterisk. The logic for running the TensorFlow Lite model will depend on the model you are using. You will need to adjust the code to fit the model's input/output requirements. Connect to the ESP32 CAM's IP address via your web browser to see the camera stream. Notes: make sure you have a compatible TensorFlow Lite model and include it correctly in your code. The model should be converted for microcontrollers. You may need to adjust memory settings in the ESP32 if your model is large. The example provided is a skeleton and requires the actual model logic to perform the detection. Conclusion: this tutorial provides a basic framework for performing object detection with the ESP32 CAM. You can expand upon this by integrating additional logic, using different models, or setting up more complex detection systems. Happy coding!